Okay, last day of Advent of Code 2022. Let's go. Day 25, full of hot air. As the expedition finally reaches the extraction point, several large hot air balloons drift down to meet you. Crews quickly start unloading the equipment the balloons brought. Mini hot air balloon kits, some fuel tanks, and a fuel heating machine. To heat the fuel, Bob needs to know the total amount of fuel that will be processed ahead of time so it can correctly calibrate the heat output and flow rate. You make a list of all the fuel requirements, your puzzle input, but you don't recognize the number format either. For example, interesting. You ask why some of the digits look like minus or equals instead of digits. You know, I never did ask the engineers why they did that. Instead of using the digits 4 through 0, the digits 2, 1, 0, minus, and double minus. Minus is worth -1, double minus is worth -2. Reversing the process, you can determine that for the decimal number 4890, the SNAFU number you need to supply to Bob's console is 2 equal. Okay. The L's are starting to get cold. What SNAFU number do you need to supply to Bob's console? Okay, this doesn't seem too difficult, but kind of annoying. All right, so I'm just going to walk through today's answer. So really, we break the problem down into two issues. We need some way to convert SNAFU numbers to decimal numbers, and we need some way to convert decimal numbers back to SNAFU numbers. The first one is pretty simple. The second one is slightly more complicated because the SNAFU, it works in a weird way compared to other decimal systems. But we'll get into that in a second. If you have both of those functions, the actual loop is pretty easy. Basically, we just take our input, we map it to the SNAFU to decimal, we sum them up, and then we send the whole thing to decimal to SNAFU. Easy enough. So let's walk into that first one. So SNAFU to decimal, basically, we're going to take in a SNAFU string, and we're going to return a long. And you are going to need a long because some of these get to like 20-something characters, which 5 to the 20th is a lot. It's way more than an int is going to hold. And then we have our total, which again, long. And then basically for every character in the string, and there's a couple ways to do this. You could do it from right to left and just multiply the digit by 5 each time. I just went from left to right, and then the power is basically 5 to the how much the string we have left. This also needs to be a long. I didn't add that the first time, and had to spend some minutes kind of debugging that. And then basically from there, what we're going to do is we're going to add to our total a win function, and when it's 2, it's 2 times the power. When it's 1, it's 1 times the power. Otherwise 0, -1, -2. And again, these need to be longs because even just times the power is going to be well over an int on some of the longer ones. Once we have that, we just return the total. That's it. So that one's usually pretty simple to run through. The second part is the decimal to SNAFU number. So we're going to take in the decimal, which is a long, and we're going to return a string. So opposite before, obviously. And then basically what I'm going to do is I have a remainder that's decimal. So normally what you would do is you would just, if you're going to like convert from base, X to base Y, you basically just take the Y's out of it, and then you subtract, and then you take the next lowest Y's out of it, and you subtract. The only reason we can't do it exactly the same here is because we have the ability to have negative numbers inside of the representation. So, like for example, decimals don't have a negative. You can't have a negative in the 5's place, but or the 10's place, but no negatives elsewhere. Like the whole number is negative or not, right? So that's kind of the one weird little trick. But other than that, it's going to basically be the same as any other decimal conversion. So the first thing we're going to do is find the biggest power of 5 that fits into our number. So we're going to start with 5. We're just going to keep multiplying by 5. When it's too big, we're going to divide by 5. And that's the biggest number or power of 5 we can take out, basically. While 5 is greater than or equal to 1, how many 5s can we pull out? And this is the part that's probably going to trip people up the most, is how to pull out all the 5s and leave the negatives in for the remainder of the string. So normally what you would do is you have something that's basically just like this. You're just going to take the remainder and you're going to divide by 5s, and then you're going to make 5 smaller and so on. You can just do that over and over. But in this case, we actually need to be able to be off by a little bit. And so that off by a little bit turns out to be half of 5s. And then also through troubleshooting, I found you also need to worry about negative numbers, because we don't want to plus it on a negative number, we need to subtract it. So if we're negative, basically multiply it by -1, and then so subtract instead of add it. And then basically what that's going to do is, like, for example, if you were at an 8, it's going to round you up to 10. And that way you still take out as if you had 10, but then now you have a -2 remainder, and then you can take care of that -2 remainder in the next step. And then, so each step through, if you have if the number of times you can divide by was 0, 0, 1, 2, that's pretty standard. But if it was a negative remainder that's left, we're going to take out a -1 or a -2 power 5. And in that case, we'll just do those. And then once we subtract it out again, it's going to turn back into positive. Well, possibly. Depends on the number. And then divide by 5s again, or divide 5s by 5 again, just to shrink it down until we get down to 1. And then all we do is then return SNAFU, and that is our answer for the day. And runs really quick. So if you got any questions or anything, of course, leave a comment. If you want to check in the code, it's on the GitHub as always. Okay, definitely still overflowing. Could that be the only problem? That's a totally different answer. Let's see, are any of these overflowing? No, none of these are overflowing. Okay. Cool. Let me grab that. And then pop that in there. That's the right answer. You're 1 gold star closer to collecting enough star fruit. Great. 10 minutes to program, 20 minutes to debug. Great. What? Okay. The hot air balloons quickly carry you to the North Pole. As soon as you land, most of the expedition is escorted directly to a small building attached to the reindeer stables. The head smoothie chef has just arrived, or has just finished warming up the industrial-grade smoothie blender as you arrive. Thank God. It will take 50 stars to fill the blender. The expedition elves turn their attention to you, and you begin emptying the fruit from your pack onto the table. As you do, a very young elf, one you recognize from the expedition team, approaches the table and holds up a single star fruit he found. The head smoothie chef places it in the blender. Only 49 stars to go. You have enough stars to start the blender. Okay, although it hasn't changed, you can still... So, wait, is that it? You make a smoothie with all 50 stars and deliver it to the reindeer. The sleigh is already warmed up by the time they finish eating. Congratulations, you finished every puzzle in the Advent Calendar Code 2022. Woo-hoo! I hope you had as much fun solving them as I had making them for you. I'd love to hear about your adventures. You can get in touch with contact me. Okay. So I guess part 2 wasn't that bad if you'd done all the rest of the puzzles up to this point. Other than that, I guess we're done for the year. I don't know if I'll do any more puzzles or anything currently. I do leak code and stuff like that occasionally just to keep my chops up, but I usually don't film them. Maybe I should start doing that on occasion. Probably be a little bit of time before I get back into it though. Anyway, I guess Merry Christmas, and I will see you guys at some point in the future.